Hello, now we're going to have a look at parallel and perpendicular lines. We're also going to look at the ideas of horizontal and vertical because they connect to our parallel and perpendicular. So we'll start with horizontal and vertical. I have a line segment here, AB. I know a line segment is a bit of a line in between 2 points. So my line segment is A and B, and it's capped at A and capped at B, so my line doesn't go out beyond those points. And this is a horizontal line. Now, a horizontal line just means that it's parallel to the ground pretty much. So horizontal, part of the word is horizon. So like if we look out at the edge of the earth against the sky, it's flat to the ground, it's horizontal. So that's where our word comes from, and we need to know that horizontal means that if we're parallel or flat to the ground. Vertical is kind of the opposite. So I have my line here with little l. I use little letters for my lines, and I use my capital letters for my points. And I have little l is vertical. That means it goes straight up and down. So vertical just means that it goes straight up and down. So straight up into the sky, straight down into the earth. Now, the other words, the main focus for today is parallel and perpendicular. So if I look at my line segment here, CD, and my line Q, I can see that they're going in the same direction. Or to put it in more mathematical language, they have the same slope. And the way that I say that in mathematical language is I have my line segment, so I have my caps around C and D, my points C and D are capital letters, and I have my square brackets that contain my line segment. Parallel, I use parallel, my two vertical lines like this sitting next to each other are my symbol for parallel, and they're parallel to the line Q. And I've used a little letter for my line. So this line segment CD is parallel to the line Q. And I've written that down here for you in English so you have a translation of it. Now again, parallel means that two lines or two line segments have the same slope. How do we say that things are the same in mathematics? We say that they are equal to each other. So again, we have M is the letter we use for slope. So the slope of CD is equal to the slope of Q. MCD is equal to MQ. And this is the mathematical way of writing our parallel. And I've written it for you in English here as well. So the slope of CD is equal to the slope of Q because they are parallel. So parallel is a very important idea. Anytime we hear parallel in maths, we're going to think, I'm looking at parallel lines. I'm thinking of equal slopes. The slopes of both lines are the same. Now, if I look at this situation here, my blue line starts at my point E, and it continues on past F, and I should have a little arrow here, it says it keeps going. So what do I call that, where I have my line starts at a point and continues on past another point? I call that a ray. So I have the ray EF is perpendicular. This symbol here means perpendicular. Looks like a right angle. It looks like a T-square, I should say, an upside down T-square. And that means perpendicular. So that means they are at right angles to each other or at 90 degrees to each other. So therefore, or they are at 90 degrees, an angle of 90 degrees to each other. And we already know about angles of 90 degrees. We can put in a little 90 degree symbol. We could put one in each of those corners. They're all perpendicular to each other. We don't generally need to write them in all corners. So we write in our right angle symbol there for saying that we are perpendicular to each other. And the ray EF is perpendicular to N. And I have that written for you in English. And perpendicular means they're at 90 degrees to each other. I'm going to write this down for you here, but you don't need to worry about it a huge amount right now. For perpendicular lines, I'm going to write you in a little formula that will make more sense to you later. So this is just a little rule that is going to be useful to you in the long run, but you don't need to worry about it too much right now. If you understand it right now, fantastic, it'll help you later. If not, we'll go through it in much more detail later on. So if two lines are perpendicular, we know we're dealing with the slopes of things when we're dealing with parallel and perpendicular. That means if we multiply the two slopes together, we would get the number -1. So if I found the slope of my blue ray and the slope of my red line and multiplied those two slopes together, I would get the number -1. Or put another way, if I have the slope of 1, it is the negative inverse or negative reciprocal of the other slope. If that makes sense to you right now, wonderful. If it doesn't, we don't need to worry about it. We're going to come back to it later on. The final thing I want to mention is when we come to more advanced problems or more English type problems in maths, we need to be able to link the maths we know to the English that we know. And an important fact would be, if we think about it, if we have a vertical line, if we have a vertical ray here, like we do for or GH, so GH is a ray, and it's a vertical line, and then we have a horizontal line like the line segment JK. These lines, this vertical line must be perpendicular to this blue line. So I would be able to write in my perpendicular symbol here. So any horizontal line must be perpendicular to a vertical line, because a horizontal line is flat to the ground and a vertical line is going straight up and down in the air. So they must be perpendicular to each other. So if we see that something is horizontal and another thing is vertical, we know they are perpendicular to each other. And that is the key facts that we need to know about parallel and perpendicular lines.